Characteristics of polynomial functions. Let's look at example 1. Example 1 is asking us to determine the key features of the graph of each polynomial function. Use these features to match each function with its graph. So these are the features. State the number of x-intercepts, the number of maximum or minimum points, and the number of local maximum or local minimum points. And you're given these functions and also these graphs. Of course, it looks much nicer on your handout, and we're supposed to match these graphs with either of the four functions that they're giving us. I'm only showing you A and B right now. So let's start by examining the first function. Right, the first function. Let's examine the first function. What's the degree of this function? The degree of this function is, we look at the highest degree and we know that it is 3. So let's write that down. And the next thing, we know that the leading coefficient happens to be 2 and it happens to be positive. And that tells us that if it's an odd degree function and the leading coefficient is positive, we know that this function is moving from quadrant 3 to quadrant 1. Okay, so I think we have enough information to be able to figure out which of these four functions corresponds, which of these graphs corresponds to this function. So it appears to be number 4, right? It's moving from quadrant 3 to quadrant 1. And yes, so let me just have it here as a reference so we can see. In fact, I'm just gonna draw it here, make a rough sketch, but it roughly looks like this. Okay, so let's have that as a reference. I mean, of course, on your paper you have it right in front of you. I'm just gonna put it here for explanation's sake. So now let's start answering these three questions. State the number of x-intercepts. So we know, we look at the graph and you know that it has 3 x-intercepts. So let's start mentioning that. So it has 3 x-intercepts. Okay, I'll just abbreviate it for now. The next question, it says the number of maximum or minimum points. Okay, so when we look at this graph, we can see that there is a maximum point here, but it is not the absolute maximum point, because we can see there are other values that are higher than that maximum point. So is there an absolute maximum point in this one? No. So therefore this function does not have a maximum point. And if you look at this point, this is a minimum point, but is it the lowest? Is it the absolute minimum point? No, because this keeps on extending to infinity. So there's no absolute minimum point. So the answer to this one, for this type of function, whether there are how many number of maximum or minimum points, we can say that there are no maximum or minimum points. There are no absolute maximum or minimum points. However, is there a local maximum point or a local minimum point, and how many? Well, yes, this is a local maximum point and this is a local minimum point. A local maximum point is the greatest y value on some interval close to that point, right? So around this interval range, this happens to be the local maximum and the local minimum. So we can say that there's one local maximum and one local minimum. One local maximum point and one local minimum point. Okay, so we already answered the possibilities for function A. We match with this graph, which happens to be 4. Actually, let's just label it here 4. Now let's look at the second example. Right, very similar. Let's start by investigating this one. We have, what's the highest degree here? It's an even degree function. It's a degree of 4. So we know it has a degree of 4. It has a leading coefficient of -1, and since we know that it's an even degree function and it has a leading coefficient of -1, then we know that this function moves from quadrant 3 to quadrant 4, which is the normal behavior for an even degree function with a negative coefficient. So which of these four matches our x to the power of 4, right? And we expect to have at least about that number of x-intercepts. So here we have this one is going from 3 to 4, and nothing else matches that. So this one is our function, right? Let's label here b before this happened to be a. Okay, so we know it's this one, and the same as before. I'm just gonna make a rough sketch here so we can analyze it. Of course, for you, it's right in front of you. Okay. All right. The next thing is, let's start answering this question. State the number of x-intercepts. So we can see that the number of x-intercepts for this one happens to be 1, 2, 3, 4. Sorry about that. Okay, so 4 x-intercepts. I'm just going to do it with green this time. 4 x-intercepts. The next one is there a local maximum or local minimum? Okay, so when we look at this graph, right, this happens to be the maximum point. Are there any points higher than this one? No. So actually this function does have a maximum point. So it has one maximum point. How about a minimum point? Well, this is a minimum point, but there are other points that are lower than that one, and these keep on going to infinity. So so there's no minimum point. So there's one maximum point, and by the way, this happens to be the absolute maximum point of this function. Right? This happens to be the absolute maximum point of this function, whereas there's no minimum point. So there's no absolute minimum because these keep on going all the way to infinity. However, and you may be able to guess it, how many local maximum points do we have? Well, we have one point here and another point here, so we have 2 local max points, and we also have one right there, one local minimum point. Okay, so we've matched so far 2 of these, and we still have another 2 that we need to work on. Right, these 2. So I want you to complete these 2 on your own, and if you have any questions, let me know.